Ready? Hi. So, well, it's 9:02. I guess we should get started on time because we have a 4 hour of agenda this morning. So yeah, we have some very excited, interesting talks for this community meeting, and so we have 3 talks. And the first we're gonna have I and Sarah from University of Tokyo and University of Kyoto. And we met in Tokyo in December and learned about their very interesting project about, a, a unikernel project that using WASM as the interface. So we're going to hear about that project in our first talk. And then in the second talk, we're going to hear about cosmonics, Bailey Hayes, about, the recently passed WASI 2.0, WASI point 2 point. Is it 2.0 or preview 2? That's what it
I
is.
will
So
I will answer it.
yeah, okay. So yeah, that's the basis for the component model, which the community has finally come together, and so the official spec can come out, and we are preparing a demo together with Cosmonic that's early next month. Well, middle of next month, I think. So so I'm very excited about that, and we definitely want Bailey to talk, to discuss more about the spec and the impact they're going to have for the ecosystem. And then last, we're going to have our own Hadai to talk about the um, the internship positions that we have with the Linux Foundation about 4 AI related plugins that we have um, for the um, for the next 3 months, I think. So, so there's he gonna talk about what those projects are and how to apply for them. So yeah, that's so very excited about all this. And so without further ado, I'll ask I and Sarah to come and talk about their project, please. Thank you.
Okay, so yeah, uh, let us start our presentation.
Yeah.
We will share the screen. Okay, can you see it?
Great.
Yes.
Yes, I can say it.
Yeah,
Thanks.
thanks. So, thank you for inviting us to the community meeting and taking time for us to introduce ourselves. We'll introduce our open source project, Mewz, a unikernel for running WASM. We are working on the project as a selected initiative and the MITO project. The MITO project is a government-backed initiative in Japan that encourages students to explore new ideas and areas. The aim is to foster technical innovation and entrepreneurship among young talents in Japan. Now, first, let me introduce ourselves. I'm Soichiro Ueda, a Japanese student in Kyoto. I love system softwares.
Hello, my name is Ainozaki from Tokyo. I love system software too and homomorphic encryption and CUDA. Thank you very much.
Yeah, well, moving on to our main topic. Now, a lot of WASM runtimes have emerged. For example, WasmEdge, W3, Was0, and Wasmer. But most of them run on general purpose operating systems, such as Linux, Windows, or macOS. We believe the missing piece is here. Why don't we have an operating system specialized for executing WASM? This is our approach. We are developing a minimal kernel required for executing WASM. By doing so, we realize a kernel specialized in running WASM. This kernel can run only one WASM application inside of it, and a kernel composed in this manner is commonly referred to as a unikernel. This execution approach represents an entirely novel paradigm for WebAssembly, and we think this will facilitate the utilization of WASM in the cloud. Now we'll explain what is a unikernel. A unikernel is a way of compose a kernel. There are two characteristics of a unikernel. First, a unikernel has only one process. This feature reduces the overhead of context switch. And second, it integrates application codes and kernel codes by statically linking them together. So the application runs in kernel mode, and this reduces the overhead of system calls. And it is proposed to directly execute unikernels composed in this way on virtual machines in the cloud. And this will optimize the execution of applications in the cloud. Now, let's thinking of running WASM as a unikernel. Conventional unikernels were designed to be linked with the application source code, but our design link wasn't binary instead of application codes with kernel codes, and turn it into a kernel image. This enables to integrate WASM and kernel implementation and run it without other operating systems. This is the fundamental idea underlying our project. And interestingly, when linking WASM binary and kernel codes, WASI works as interface between WASM and kernel codes. WASI enables linking WebAssembly with unikernels. That's why we think WASM and unikernels are well suited for each other. We'll now explain the detailed design of it.
So let's see architectures of Mewz. Mewz architecture consists of 3 components, and I will introduce each of them. First is Mewz, unikernel for running WASM. As shown in the picture, users build WASM application from programming languages, and he can execute the WASM binary as a unikernel on hypervisors. Mewz provides WASI as an interface between kernel and application. We currently support WASI Preview 1. So how we can execute WASM in unikernel? This slide shows the compile flow. First, we compile WASM binary to object file by our compiler. Next, we can link the generated object file with unikernel and get kernel images. In this linking time, the invocation of WASI from WASM binary combines with WASI implementation in Mewz. Finally, we execute the kernel image on bare machine, which means without any other operating systems. This is how to execute WASM as a kernel. And the second component is WASCAR. This is an ahead-of-time compiler for WASM. WASCAR uses LLVM as a backend. The most important feature of WASCAR is it leaves invocation of WAS unresolved. That means we can link the outputs of WASCAR with any WAS implementation. So WASCAR is not only for Mewz. WASCAR enables run WASM applications on various kernels. The last component is Containerd sim Mewz in LangWASI. LangWASI is a project under Containerd, and LangWASI is a layer for running WASM runtime by Containerd. We make Mewz support LangWASI. So as shown in the picture, Containerd is invoked from Kubernetes as a high-level container runtime. And thanks to the Containerd sim, we can use WasmEdge or Mewz as a low-level container runtime. We will demonstrate this later. So this is an overview of system architecture. Users can run their WASM binary on Mewz unikernel. And this unikernel can be used within the container ecosystem. This means that we can benefit high isolation and low overhead of the unikernel without being aware that this is a unikernel.
But what are the benefits of running WASM as a unikernel? How is it different from running WASM as a user process on conventional WASM runtimes? Let's think about running WASM on public cloud. Generally speaking, for security purposes, high isolation is required for workloads in public clouds. So we think running WASM on public cloud will require isolation by virtual machines. Actually, containers also require VMs because they share the host kernel. WASM runtimes also share the host kernel. WASM is known for its ability to execute code securely with sandboxed environment. However, in modern cloud environments, it has become common to isolate using virtual machines and not share kernels. Then the entire environment will be like this. WASM applications are executed on WASM runtimes, which run on the Gets kernel, such as Linux. Despite the lightweight nature of WASM as an execution environment, it's accompanied by virtual machines, adding additional layers of complexity. This entails the overhead from virtualization. But with Mewz, WASM applications run with dedicated, extremely thin guest kernel. So this architecture reduces the overhead from guest kernel. This allows WASM to run on virtual machines with minimal overhead. Moreover, thanks to the portability of WASM, users don't need to be aware that the application is running on a unikernel. That's why we think Mewz will be the optimal choice for executing WASM on public cloud with high isolation. Now, we'll show the demo video of running Mewz via Kubernetes. First, the Kubernetes cluster has no pods. Here is the manifest of Mewz pod, and apply it. For comparison, here is the manifest of WasmEdge pod, and apply it too. Then we have two pods of Mewz and WasmEdge, and we can access these pods via HTTP. Here are the responses. Yeah. And this is the performance evaluation of Mewz and WasmEdge. Mewz run directly on KVM virtual machine, and WasmEdge run on Linux on KVM virtual machine. So both run on virtual machines. And the benchmark result shows that Mewz is 30% faster than WasmEdge. We think it's because Mewz reduces the overhead from guest kernel. In this way, Mewz demonstrates its effectiveness in optimizing WASM execution on virtual machines. And Mewz and Wasker are open source projects. We publish them on GitHub. Please check out them, and we appreciate it if you give us stars for them. In conclusion, we are working on a project to run WASM as a unikernel. We are developing Mewz, a unikernel specialized for executing WASM, Wasker, an AOT compiler of WASM, and container dishing Mewz. We think it will optimize execution environment for WASM on public cloud with high isolation. Thank you for listening.
All right. Thank you so much. Yeah, that's you can go back to the slides where you have your URLs so that people have a chance to look at your links and your QR code.
Oh yeah.
Yeah, that's great.
Thanks.
So we'll leave most of the questions to the end. But I just have a very something I just have to ask. So you have demonstrated that you 30% faster. How much smaller? Would you be able to talk about that? That's
Smaller?
yes. So I would imagine the unit kernel is smaller than say WasmEdge running on Linux, right? In terms of image size.
Image size. Image size. Actually, we've not compare the kernel image size, but
Okay.
yeah.
Yeah. I'm just curious. That's maybe that's something would be interesting to compare, and also memory usage, right? Because those are the obvious things.
We'll do additional evaluation. Yeah. And
All right.
this HTTP server is written in Rust and compiling to WASM, and I think it was about 2 megabytes or 20 megabytes, and yeah, but Mewz and Wasker compiled the WASM binary into an object file, and the size is not so different, almost the same. But the object file, and we link the object file and Mewz implementation and make kernel image. But it is also not so different, and so the kernel implementation is about a several kilobyte, and yeah, so this order. So yeah, I think the Mewz implementation is very, very thin and lightweight in
Right.
kernel image.
That's great. Yeah, that's because on the Linux side there's slim containers and things like that which could make it but I don't think I think it's still in the tens of megabytes. I may be wrong, but but yeah, that's regardless, that'd be interesting to see those numbers. Really impressed by your work, and really appreciate the presentation. We'll leave other questions to the end. So if people are interested, if you're interested, think about some question. That's so that we can ask I and Salah here. So thank you very much. All right.
Thank you.
So yeah, so speaking of using WASM and WASI as an operating system, so I think it's a good time that we introduce our good friend Bailey, to talk about a new advancement in WASI. That's so there seems to be great progress has been made in the past couple months. So Bailey, please. Yeah.
Let me share my screen.
Mm-hmm.
Okay, can you see that okay?
All right, yes.
Excellent. All right. So yeah, we've made a ton of progress. I will say that this effort in a lot of ways started since 2019. And I will be giving you the current state of the world. Just know that between 2019 and now, there was a lot of evolution and a lot of changes. And so sometimes that can mean that things may seem a little weird. So I'll try to highlight those everywhere that might have happened. So I'm talking today about WASI P2. I will go into some of the different naming stuff on the next slide, but effectively, this is that next iteration of WASI Preview 1 that came out in 2019. And as you're probably familiar with, WASI Preview 1 gave you the ability to run WASI outside of the browser because it provided a monolithic ABI that said, hey, here are all basically the syscalls that I need to make to be able to be successful, to compile programs that can run. And this Preview 2 has basically all of those same interfaces exposed within WASI CLI, but there's actually some new stuff that's pretty cool, and I'll highlight some of those. This vote was held January 24th. I'm the WASI co-chair. And so I got the honor to basically hold this vote, and some of the phase process and stuff with standardization can be confusing. I included a link to it, but basically what it meant is that it had progressed to a level that was stable. We had two effectively definitions, WASI CLI and WASI HTTP proxy, and then those also had two reference implementations, one allowing it to run in WASM time, and the other being able to run it in Node.js, which is pretty cool. And this is one of those things that I was going to highlight that might surprise folks, because if they remember what WASI Preview 1 was, which was very much about running outside of the web, this is now very much about running everywhere. That's one of the key differences between WASI Preview 1 and P2. So the name, it's kind of confusing, right? We don't love that we've kept that preview name. We knew Preview 1 was pretty far away from an MVP, pretty far away from what we wanted. And so giving it the preview name was trying to put up all the flares, like we're definitely changing this. And it might really change. But the reality is that as we've been iterating over the years, we've come up with something that's super stable, that's versioned, that is adaptable too. And I'll dig into a little bit how that works. But basically, we've got something that can continue to live on, and we want people to build in production with this. So we've always been calling it WASI Preview 2, because when we started in 2019, the next thing would be, the next iteration would obviously be from Preview 1 to Preview 2. But that does not inspire confidence. It does not inspire people to want to build on it. So I'm working with Dan Goman to propose a different name, which if you listen to me, I call it WASI P2. And the reason why is that it's kind of like WASI Point 2. This third bullet here is what it basically is. So I really hope that that part changes. The next part that's kind of confusing, and you'll see in a bit, you might not think that WASI HTTP, for example, an HTTP interface is something that would fit in the category of a systems level interface. And once I show you some of the other interfaces that are in the pipe, like WASI Cloud with a key value interface, and you're like, that's definitely not a systems interface. And so we already have a proposal to rename WASI to stand for WebAssembly Standardized Interfaces, basically common interfaces that we go through an open standards process that lets us define a set of interfaces that let us run in whatever target environment we want to target. And so speaking of target environments, we have this definition of what we call worlds. And in P2, there are two worlds. There's WASI CLI and WASI HTTP. WASI CLI is very much like WASI Preview 1 with some extra stuff that I think everybody will be into, including sockets. So if you've been dealing with WASI Preview 1, you'd be excited to see sockets. There are some other additions. So WASI clocks, for example, doesn't have it yet, but will soon have time zone information in it. So there are different pieces here where each one of these individual interfaces, WASI IO, clocks, random, file system, and sockets, themselves are modular. And so a single world, you can imagine a world being a lot like a profile in that when I compile to WASI CLI, I'm saying I'm targeting the CLI world. I want to run as if I were a CLI. And that means that I export a run function, and I have imports for things like this. I basically want to run on a kind of a POSIX-like system. And the other part here, I included the portability criteria in that to be able to say WASI CLI is ready and part of P2, it had to be able to run on Windows, Mac OS, and Linux. Emphasis on Windows here, because that was not as easy as it might seem. And then it also had two complete independent implementations. WASI HTTP is this other one that I kind of consider a little bit more of a high-level interface. Not so high level that I necessarily expect users to code directly to it. WASI HTTP, what I hope to see with it is that it shows up in all the major standard language libraries, so that when you target WASI P2, And then you can just use the built-in HTTP client that's inside the standard languages. So an example would be if I am building with TinyGo and I'm targeting WASI P2, and then I'm also able to use net HTTP module. And I don't really necessarily am writing stuff that says WASI, all those things, because the WASI HTTP API itself is very verbose. And it's verbose necessarily because to work really well with other people embedding clients across all these different standard language libraries. So those are the two worlds. One last thing that's important to recognize about WASI P2 is that we are allowing other worlds to show up for, the next, I would say about, 10 months before we have the next major breaking iteration, and that's going to be P3. What goes inside P3 is for supporting native async. The way that we do that today in P2 is all inside this WASI.io interface, and it's got this primitive type called a pollable. It also has support for streams. So those two things basically work in a lot of ways like callbacks inside the host that supports WASI.io. It's got this table of all the pollables, and so it knows how to help you do async work effectively. And so the goal is to push this down into what we call the canonical ABI. And I'm going to hit on that in a little bit next. But first, just to inspire confidence, the WasmTime implementation, one of the reference implementations, it has this giant test suite. We did reuse the same test suite for verifying the JCO and Node.js implementation. We're actively also working with JCO to also make it work really well for browser environments. But there's some tricky bits around the fetch API that was a lot easier to solve inside Node.js, and that's why we don't have it immediately today, but it's getting worked on. I hope to see it in the next couple months. But yeah, tested all these platforms, so we're feeling pretty good about it being portable. Now, there's this other word that I've been avoiding a little bit, and that's components. So within WASI P2, it's built on top of this new thing that we created that's almost like a new language in a lot of ways, but it builds on top of all of the existing core WebAssembly specs. And so as you can guess, a component is composable. I'm able to compose two components together. And it really is metadata that wraps around a core WASM module or multiple WASM modules. And one of the reasons to support components in this way is that I'm able to make it language interoperable so that I can have a Rust component talk to a Go component. But the way that they talk to each other is through these imports and exports, which are high-level interfaces, those same interfaces that I was showing before that we standardized for WASI, but these could be your own interfaces because one of the main changes inside P2 is support modularity. So you can design your own, which is really valuable for a lot of folks that want to design new things. And so the third key property that components build on top of existing WebAssembly properties is that it supports fine-grained sandboxing. So basically, each component has its own linear memory. For a runtime to implement components, it also has to support basically the multiple memory proposal. And so when I compose two components together, component A and component B, I get out component C. And component C knows how to instantiate both of those two subcomponents. This is cool in that you can do things like saying, I don't necessarily trust component B because that's some third-party library from my business logic in A. So this diagram I created with Kate Goldenring. Now the next diagram here, this is Kate's diagram showing off one of the ways that you could use components. And so we gave a live demo of this at WASM Day, at our last WASM Day. And what we did is we took an authentication middleware component. This was just what's a common component everybody has to deal with in the cloud native space? Well, that's probably one. And then we were able to compose them together and then slot them into a WebAssembly host. And WasmTime has the serve function that makes it really easy for you if you have a component that targets the WASI HTTP proxy world, then you can run WasmTime serve with it and then be able to run it. Pretty much vendor-free, which is pretty nice. Jayco's got another kind of run trick, but I'm not as good in JavaScript and Node environments, so I didn't mess with that, but in theory it works. And yeah, so this is kind of that nice composability. And so you can imagine that these components can have any number of them in it. And so long as the WebAssembly host supports those imports, basically, so the host itself exports those things. Exports are these kind of like little nubbins here going up like a Lego brick. That's an export, and then the component itself imports that. So in this case, the component is importing WASI CLI environment, and the host is exporting WASI CLI environment. And so that's how it's able to slot in. So you might be wondering, hey, what's the key difference between a module and a component? Well, not a ton, actually. The main difference that I would show is that a component basically wraps a module or multiple modules with high-level interfaces. And the interface that I picked here was totally on purpose. I'm showing off that the logging interface allows me to pass in a string. And if you've messed around with modules before, you know that you kind of have to have an agreed upon way of taking the string, the way that it's done in Python or Rust, and it's different per language, and stuff that into your core module inside as I32s. And so because we have basically these high-level types now, when I compose two components together, there's this part of the system called the canonical ABI that lets me compose them together so that I know how to lift and lower types going from core WASM module types to the component level definition of those types and back down again to that other component. And that is how I have language interoperability. That's the key here, and that's what this enables. So let's say we crack open a component, like let's look like what does it have under the hood? So that import for logging, see it's the downward nubbin, and then that export of run is the outward nubbin. But the reality is that what's inside, it's still a core module, and it's still all the same core WebAssembly specification stuff. And it takes advantage of being able to use multiple memories so that you can have multiple core WASM modules and components that talk to each other. And so if I were to run this component on any of the systems that exist today that support components, I would get the exact same performance profile as if I had a single core module, because all the compute is still right there in that same core module. Now, this is like that part where, you know, hey, I'm the CTO at Cosmonic. And so one of the things that I work on, I'm a maintainer of WASM Cloud, which is another CNCF project. And Cosmonic is the managed version of WASM Cloud. Well, we support 0.2 right now, P2. But there's another key part of why you should trust us when we say it's time to move to P2. And that's all these interfaces are versioned. And not only that, they support multiple versions at the same time. This is that superpower that lets us move as if it was a peninsula of stability, in that if you start working with P2, we can now move you along into the new versions, let's say once P3 is available. And that's extremely powerful. It's something that we really had trouble doing before. There's a reason why 2019 was the previous iteration of WASI, because when you have one single monolithic ABI, it's really hard to grow it forward because you have to have agreement across everyone, everywhere. Whereas this is like, actually, I need to hold a vote for Blob Store. And that's the only thing I'm checking. That's the only thing I'm verifying. And Blob Store moves independent of everybody else. That's really nice. And so the trick of how we got modules to support components is that we have this thing called an adapter. We call it the WASI Preview 1 adapter. And so if I run the command WASM tools component new, taking a single WASI Preview 1 module, I can output a new .wasm that has that component metadata around it. And it is adapted itself with a WASM module, which is kind of cool. But it's a special kind of adapter that knows how to take those previous APIs and then match them to the new ones. And we can continue to do this type of technique as we grow the interface. You know, as we change things, we can continuously add more adapters without the end user ever having to recompile their code, right? You give me a compiled artifact, a .wasm, and then I can continue to adapt it forward in the future. And so platforms are pretty excited about this because that means that our users necessarily don't have to deal with this problem. When they recompile, they get the new stuff and it's all great, but they don't have to. Our platform can support it. I've hinted on this a little bit before, but right now we are at WASI P2. It's stable. It's starting to get integrated into all the language SDKs, which means basically many years of support is ahead of us for WASI P2. The next addition is WASI 02.1. And we expect throughout the year to have several more of these. And it'll add things like forwarding and splicing of streams, time zone support I mentioned for WASI clocks. I think we'll have several more additions that we'll add that people are really excited about. Personally, I'm really excited about dictionary types. So if we get those dictionary types in, we're going to create, it's purely additive. I do want to highlight that non-breaking changes only so that it's backwards compatible. But by the end of this year, the goal is to have a new iteration of the component model that supports native async. And what that'll effectively do is take most of the stuff that's in WASI.io and merge it down into the component model so that WASI.io doesn't really have much of anything in it anymore. But that itself will be the breaking change. However, we'll be able to continue doing our adapter technique to take folks that are on P2 and adapt it to P3 without them having to recompile their code. So that's pretty cool. And then after that, we're building towards MVP and we're on the path to like official standardization. And that's why we're still giving it the major version 0, because we know we haven't quite hit the MVP of what we want to build with all of this. At the bottom here, I highlighted some of the different other worlds that I'm aware of that people are really excited about. WASI Cloud's one of the ones that I work on. WASI NN has been around, but there's a lot more that folks want to do there, which is cool. And then some of the new stuff, I've been hearing about people being really interested in different types of hardware interfaces. And so there's one idea being floated that's like, well, maybe we need sort of an embedded world so that you can target an itty bitty place. Then for WASI Web GPU, sort of the same idea. Like, let's build something that helps us target graphics applications. So that is a little bit on the WASI backwards compatibility. I tried to make this pretty quick. I know that there's a lot of depth here. So Michael, you said you wanted to hold questions to the end, so I can just stop sharing now.
Yeah, thank you, Bailey. I definitely learned something today. That's so are you really saying that we can start a HTTP server in the browser now?
Kinda, yeah, with
Okay.
hacks. So the way that it works is, I said hacks, shims. That's the word that these JavaScript people tell me they use. So inside Jcode, they've got this piece called WASI shims, and that piece is actually mostly JavaScript glue that kind of like funnels it so that your code says, oh yeah, I'm an incoming handler. I just work with stuff. So when you get called, you handle things like you would handle it with any other HTTP. So it's not quite like a server, but a proxy is very much how I would describe it.
That's definitely would be really interesting because one of I'm sure you have seen this a lot at Cosmonic as well. A lot of people wants to start web servers in WASM like they used to do in Java, right? So it's so to have the HTTP interface everywhere, I think it's really valuable. And in the past, we would have to patch and manipulate those common libraries in different languages in order to do that. But I'm really excited to see a potential new way to have this built in as a standardization as a path forward. That's yeah. Thank you for your great work in this, and we also look forward to supporting the preview 2 and the component model, and to have something to demo fairly soon. Yeah, that's
that's going to be a really fun workshop. I can't wait to watch it. You and Brooks.
Yes. All right. Yeah. So we'll keep that question to the end of the talk, and we're talking about the other world, the WASI and the targeting, say GPUs and machine learning frameworks and all that. So that's if you follow us on Twitter, if you follow WasmEdge on Twitter, you know that's this is one of the major focus that we have. So at least at this moment. So so we actually have several internship positions that's coming up around this area in our WasmEdge community. So I asked Haidai to talk about those.
Sure. So let me share my screen now. Issues. Okay. Can you guys see my screen? It should be our GitHub issues. Okay, great.
Yeah.
So actually, because our recent focus is to push more LLM backend and machine learning or AI backend into the WASI neural network proposal. So we provide full full projects in this period of the LFX mentorship. And actually, it's pretty interesting because if you check all of these full projects, you will find out that the MLX is provided by Apple. Just the name, this extension for transformer is provided by Intel, and this is the author of the Lambda CPP to create a whisper model, which is original provided by the OpenAI, and also Bernda as a ROS framework of the machine learning related framework. So to integrate all of this, that's our major purpose in this period. So let's get into each one and to talk about why we choose it and why it's important that we hope implementing to integrate and to execute the LLM on it. So first is MLX. And actually, I believe most of the people to run an local LLM on their devices is using Mac OS. The reason is that I believe not everyone can afford A100 or Edge 100 card from NVIDIA because it's extremely expensive, right? And you must have a blend server or something like that to install the GPU card and run a very large model. However, if you buy an Mac Pro, you can have a super large VRAM on it to load those big model and run it on your own cloud. So that's why we hope we can integrate the MLX, and for those who deploy their self LLM service on Mac, especially if they are interested to deploy the 70B or more large model on it, they will choose MLX and Mac Pro as their first priority. So that's why we use it. And to apply this, I believe you must have the environment to install the MLX. For example, you must have an environment wherever you get the environment. For example, you have MacBook or you rent the AWS server with the Mac Mini M1, or you use GitHub code space. I believe now the GitHub provide the Mac instance now. So you must have the environment to at least build and test the MLX backend. And then you have to know the WASI neural network spec, because all you need to do is to wrap the backend into a very limited and specific WASI neural network function and resource type. And also we maintain a fork of the WASI neural network is because that when you use LLM, you will need some special error handling and some cancel function because the execution is pretty long. You may not want the model to, execute the full process and without any interrupt. So we modify a little bit spec and to do an extension. Actually, I just took this, this change in the WASI neural network meeting yesterday. So if you're interested, you can go to the WASI neural network proposal and to check what's the difference between our extension and the original one. And we are talking about how to push this extensions into this official proposal now. So that's our first framework to do. And we have the Intel extension for transformers. The reason is that I believe most of the people, if you are not buying an Mac, you are using any PC, the most easy thing you can get is the Intel CPU. Yeah, so we hope that more people can use the Intel extension for transformers to accelerate the inference on the Intel CPU machine. Actually, this request is from lots of the community members because they said, "Hey man, you said you have used CUDA, so I have got lots of the NVIDIA machine, which is super expensive. However, if we can take the same cost on AWS, we can rent hundreds or thousands of the CPU machine to do the inference. So that's why they want to move their focus from the GPU into CPU. That's why we choose the Intel. So if you are using this, I believe to have an Intel machine is a basic requirement because you must have to test it. But I think it's super easy to get it. Yeah. So this too will require a hardware limited than the other proposal because the other project do not have such requirements. For example, the Whisper.cpp is pretty cross-platform. You can build it on Windows and Linux and Mac with any architecture. I believe the ARM64, the Intel, the AMD64 are all supported. Yeah, and this framework is a very interesting thing. Is that actually I use the LLM to help me to learning Japanese, and a key component is that I hope that when I talk about a language, the LLM can help me to translate it into text. So the Whisper is a model to convert your voice into text. That's why we want to have it because we believe this is important things in the nowadays application. And I believe in next mentorship, we may have a text to voice inference. Yeah, so that's our future world. And the last one is that all you can see here, the MLX, the Intel, the Whisper are all written in C++. And we know a lot of people from our community is using Rust. So that's why we choose Urban.is because we believe Rust is also a very important language, and we hope to increase our community member and reach more people who use this language. That's why we choose Urban.is. And another thing is that just like Bailey's the slide, and they talk about the WASI GPU. Actually, we choose Urban.is because that he has the native web GPU support. I believe it's super grateful people, so they don't worry about, oh, I have an AMD GPU, I have NVIDIA GPU, and I have an Intel GPU. How could I use all of them? It's a big issue if you want to handle all of these dependency. So that's why we choose the Urban.is. So because this is pretty new, we try to know. So when you choose this proposal, this project, you may encounter some, unknown Rust relative plugin issue because we only have one Rust plugin. It's called the Rust TLS library. That's all we did before. However, we have several sets of the C++ version. So that's why if you choose this one, and we believe you will have more communication with us because we may have to work together to figure out how to make this integration more smoothly. Yeah, so that's all I have of these full projects. And please make sure if you want to apply it, you have to finish the pretest. And the pretest is pretty easy. Is that we want you to prove that you can have the environment to build an execution which framework you want to implement in this mentorship. Yeah, so this is the minimum requirement that the pretest does. Yeah, and please check the timeline. I believe it still have some time for you guys to submit the application, and we will review your pretest. We sorry, I forgot the date, but we have announced it before. So please check all of the deadline. If you submission is expired, then we cannot review it after the deadline. Yeah, so that's all I have. Thank you.
All right, thank you, Hadai. Yeah, that's by the way, I would also add that's the web GPU stuff is actually a lot of several container environment are considering supporting the GPU architecture through the web GPU spec. Because let's say Docker. In the past, if you want to have access to the GPU, you have a special Docker shim, and that Docker shim would conflict with, say, the Mewz shim or the WasmEdge shim, right? Because you can only install one shim. So that's sort of was a problem that we had in the past. So but if there's a web GPU interface, there would be it's more standard or abstract way to access the hardware through containers. So we thought that was very interesting because that's complementary to what we have been doing at WASM level as well. So so if you know someone who's interested in this kind of thing, that's we'd love to have them apply. By the way, all those are have stipends as well, so they are paid internships, and so that's I love the 3 talks today. I think to me, WASM has really come to become the universal interface language, or the universal bytecode. In the first talk we saw. You compile to WASM and you can run a Unix kernel, you can run different hardware. And in the second talk, we saw, you can do, soon we'll do standard libraries and, do HTTP servers in the browser. And, and on the server, that's, the new standard really provide new ways to get all those standardized. And in the third, you saw there's you can write to WASM, and then let the WASM runtime choose the best execution engine for you. If you be it on the Intel CPU, it choose the Intel transformer. When it's implemented, it choose the Intel transformer. On the NVIDIA system, it choose the CUDA library lambda.cpp, to perform the task that you want. And there was a slide in Bailey's talk that I also find very interesting, is multi-language interoperability. That's because I was reminded the Rust Foundation just received the grant from Google yesterday, right? To improve Rust interoperability with C++, which is also a subject that we deeply care about. And by having WASM as the intermediate layer would be, I think, would be a new approach that people haven't really thought about that much. But we intend to to talk about this as in the community as well. So yeah, that's enough for me. We have a couple minutes. So let me see the chat. There's see if there's if there's questions, please you can. I don't think you can unmute yourself, but you can ask in the chat and we can we can answer here.
A
Yeah,
good
well,
place to ask questions. I would love to funnel people over to the Bytecode Alliance Zulip. I guess I
why
should
do you
say
guys
my
have to use
affiliation.
Zillow?
I prefer Discord if I get to pick one, and Slack, but yeah. Ooh, okay. You've got one here.
What are the process removed that made unikernel WASM faster? So what do you guys remove to make it lighter and faster?
So it the question is why unikernel is fast because of removing some process, some codes. Yeah, I think is the question. And sorry, let me read. Other than HTTP speed up, what other improvements observed? So let's think about existing codes on virtual machines, on Linux on virtual machines. Application codes make system calls, and application codes jumps to the kernel calls, and kernel calls operate hardwares emulated by hypervisor, and then the codes jump to the virtual machine monitors code, and then it operates the physical machine. So the two-layer exists, and application codes and kernel codes and hypervisor codes. But in unikernel, application codes and kernel codes are statically linked, so it is integrated. So on unikernel, all the application made system calls, but application in unikernel, the application can directly call kernel calls, and then kernel calls operate emulated hardware. So the layer is reduced. The first layer is removed. So yeah, that's why a unikernel is fast. Yeah. So guest kernel is the application itself is a guest kernel. So
Yeah, that's
do you understand? Yeah.
Appreciate the explanation. We'd really love to see, this machine learning stack working in unikernel, because that's a major pain points, right? So if you look at PyTorch Docker image, that's like 5 gigabytes. So if we can only include the static link, the necessary library in it, I think that would go a really long way. Right now we, with WasmEdge on Linux, we can reduce it a lot. But if we can static link those all together with hardware optimization, that'd be I think would be a great use case. Yeah.
Yeah. So web CPU might be the key. Yeah. Key for Mewz. Yeah.
That's great. Yeah. So there's the other question is about how to apply for the internship. So Haidai, do you want to add more to it?
Sorry, I think I already replied in the chat. But
Okay.
yeah, so he has a question. Do we expect a proposal to submit it for LFX along with the pretext? The answer is actually you have to submit your proposal first, and then you can finish your pretext later. The whole deadline is please follow our the deadline announcement. Yeah, so there's a thing, and another thing is what are the preferred checks you will see for finding a good candidate for the mentorship, since most of us may complete the pretest successfully? Actually, we will depends on your repo and your GitHub repository and how you write the repo, how you commit, and how you write your commit message and lots of things. Especially with your resume, if you have other very stunning projects or very awesome project you have done before, please make sure all of them are attached in the resume. Yeah. So we as I just talked a few minutes ago, the pretest is to verify that you have the basic environment and ability to develop our project. It is not to show how it's not a legal challenge to verify how good you are how good you are writing an algorithm or how better code you do. No, the pretest is not doing that proposal. Okay.
Yeah.
So that's all the questions.
Yeah. Thank you, Haidai. Yeah. So we have been running those mentorship programs for a couple of years now. So we have I wouldn't say hundreds, but I think at least 30 students that has passed through those programs. And we have found, what skills do you have? It's important, but not critical. That's you can always learn that on the job. But we do want people who can make the commitment. Because sometimes people apply for like 10 of those, and then which one sticks, right? So they are not really committed to do those. They don't have time, and things like that, and that causes problems down the line, because those are all paid internships, and we have to deliver something, and something of value to the community, so that the sponsors, essentially people paying the membership at Linux Foundation would see a valuable result coming out of those internships. So so in those later projects, we now have the pretest, essentially to make sure that you have the necessary commitment to do all those, so that's also to reduce the number of applicants that we have to evaluate. So yeah, that's that's why there's a pretest. It's not super complicated, but it does require some time, and some work in order to get there. So yeah, well, yeah, that's so I super excited about seeing progress from all the talks from in the community meeting today. And as I said before, next month we should have a WASI HTTP a preview 2 demo running on WasmEdge now. Right now we run a lot of HTTP servers on WasmEdge. Right now I have a server running for one of our customers. We have a A100 GPU we run 10 WasmEdge workers. Each worker has a large language model attached to it. They all reside in that 80 gigabytes memory of that A100. And then we have a Nginx load balancer sitting in front of it. I have been running that for 2 days straight with GPU load at 100%, right? So to see how stable, how feasible it is to serve, say, production-ready machine learning workloads through HTTP in the real environment, it has been pretty stable, you know, and but of course, the challenge has always been that we have to maintain our own patches and forks of standard libraries. You know, Seven was on this call earlier, and I think he had to leave. You know, Liquid Reply, you know, that's our German company has helped us to maintain a lot of those forks, and which is a hassle. But we really want look forward to the Preview 2 world where all those are built into the standard libraries like Tokyo and Hyper in the Rust side, and Fetch HTTP serve on the Node.js and JavaScript side, and also in Go and the other languages. So you know that's I think we're gonna make the first step. You know, WasmEdge community, of course, you know, that's because I know some of those has been implemented in Wasm time, but in due time, we can also be able to talk about, you know, how's the underlying runtime implementations are different, and how we handle asynchronous sockets to make those HTTP requests fully asynchronous. Like I said, you know, we have a server that running on, you know, 24/7, you know, at 100% CPU and 100% GPU, you know, doing those machine learning inference stuff, you know, through HTTP, you know, so to do this in an asynchronous manner, so that when new requests come in, they don't have to be rejected, they can be queued, and you know, things like that. So yeah, that's very excited about all those, and